Hello, science fans. Let's talk about something truly brilliant. I mean that literally. We're going to talk about the sun. The sun isn't just a big, bright light in the sky that makes our days warm and our ice cream melt. It's a gigantic, fiery ball of gas, a star blasting energy out in all directions. Think of it as a massive power plant floating in space that's been running for billions of years. That energy travels through empty space as light and as heat. When it reaches Earth, we call that solar energy. It's energy from our star, the main source for almost all life and energy on Earth. So why is solar energy so important? For centuries, we've gotten energy by burning things: wood, coal, oil, gas. That powered our cities and our cars, but it also creates a big mess. Gases get released into the atmosphere and change our climate. Not great. Solar energy is different. It arrives every day for free. It doesn't need to be dug up. It doesn't need to be shipped across oceans. And using it doesn't create pollution. It's clean, it's quiet, it's incredibly powerful. Harnessing it is one of science's coolest achievements. We've learned to catch sunlight and turn it directly into electricity. Electricity that can power your television, charge your phone, or run your entire house. Imagine making all the power you need on your own rooftop. It's not science fiction. It's real and happening worldwide. Understanding this is the first step to a cleaner, brighter, sustainable future. This is a big deal. Shifting to the sun is a huge step forward. We're moving away from old, messy ways and into clean power. It's like swapping a century of junk food for a superfood that powers everything. Solar energy protects our environment, makes communities more resilient, and puts power into people's hands. Let's begin our adventure at the source, the sun itself. Our sun is about 93 million miles or 150 million kilometers away from us. That is a mind-bogglingly long distance. If you could drive a car to the sun at highway speeds, the trip would take you over 150 years. Yet light from the sun makes that epic journey in just about 8 minutes. That's right. The sunlight warming your face right now left the sun only 8 minutes ago. This light travels in tiny packets of energy called photons. You can think of photons as little messengers, carrying energy from the sun, delivering it all across the solar system, including right here to our beautiful planet Earth. These photon messengers are shot out from the sun in every direction like a sprinkler spraying water on a giant lawn. Billions upon billions of them race through the vacuum of space at the fastest speed possible, the speed of light. As they travel, they don't get tired. They just keep going until they bump into something. Luckily for us, our planet is in the perfect spot to intercept a whole lot of these energy-packed photons. When they arrive at Earth, they have to pass through our atmosphere, which is like a protective bubble of air surrounding the planet. Some photons get bounced back into space by clouds or dust, but many of them make it all the way down to the surface. So how do we catch these speedy photons? We use a device called a photovoltaic cell, or a solar cell for short. Now, photovoltaic is a big word, but let's break it down. Photo comes from the Greek word for light, and voltaic is named after Alessandro Volta, a pioneer in the study of electricity. So, photovoltaic literally means light electricity. That's exactly what these cells do. They are specially designed to convert sunlight directly into electrical energy. A solar panel, the kind you see on rooftops or in large solar farms, is really just a collection of many of these smaller solar cells all wired together in a sturdy, weatherproof frame. These solar cells are made from a very common element found all over the Earth: silicon. You might know silicon as the main ingredient in sand and glass, but for solar cells, we use a very pure, specially treated form of silicon. The surface of a solar panel is dark, usually black or a deep blue. Think about wearing a black t-shirt on a sunny day versus a white one. That's because dark colors are great at absorbing light and its energy, while light colors are better at reflecting it. Solar panels are made dark on purpose to absorb as many photons as possible and not let that precious solar energy bounce away. When you look at a solar panel, you'll see a grid of these dark squares, which are the individual cells. These cells are protected by a sheet of glass on the front to keep them safe from rain, hail, and dust. All right, let's zoom in, way in. We're going down to the atomic level, inside one of those silicon solar cells. This is where the real action happens. The silicon in a solar cell is treated in a special way to create an electric field. Think of it like a slide at a playground. One side is at the top and the other is at the bottom. In our solar cell, we create this slide by putting two different layers of silicon together. One layer has a negative charge, meaning it has some extra electrons just hanging around. The other layer has a positive charge, meaning it has some empty spots where electrons would love to be. The area where these two layers meet is called the p-n junction. Now here comes our photon. Remember that little packet of energy that traveled all the way from the sun? When this photon smacks into the silicon cell, it transfers its energy to an electron. It's like a game of billiards. The photon is the cue ball, and it hits a stationary electron, knocking it loose from its atom. This newly energized electron now has enough power to break free and start moving around. It's like a kid at the top of that playground slide who just got a little push. The electron is excited and ready to go somewhere, and that electric field we talked about is what tells it where to go. Because of that built-in electric field, our playground slide, the freed electron is pushed toward the negative side of the silicon cell, while the hole it left behind is pulled toward the positive side. This separation is the absolute key to the whole process. So, we've created an electric current inside the solar panel. Fantastic! But the electricity produced by a solar panel is a specific kind called direct current, or DC. This is the same type of electricity you find in batteries. Your phone, your laptop, your car's battery. However, the electrical grid that powers our homes and most of our large appliances uses a different kind of electricity called alternating current, or AC. The outlets in your wall provide AC power. So we have a bit of a mismatch. We need a way to change the DC electricity from the panels into the AC electricity our homes can use. This is where a crucial piece of equipment called an inverter comes into play. The inverter is the brain of the solar power system. It's a box, usually mounted on a wall near your main electrical panel, that takes the DC electricity flowing from the solar panels and cleverly converts it into AC electricity. It essentially inverts the current from a straight, steady flow into a current that alternates back and forth, 60 times per second in North America. Once the inverter does its job, the solar-generated electricity is now perfectly compatible with your home's wiring and all the appliances you plug into the wall. Solar panels, DC. Inverter, electrical panel. Home appliances, AC, and power grid. From the inverter, the AC electricity flows to your home's main electrical panel, also known as the breaker box. This is the central hub for all the electricity in your house. At this point, something really neat happens. Your home will automatically use the solar power first. Lights, your refrigerator, your computer, they will all be powered by the sun. You won't notice any difference at all. One of the most fantastic things about solar power is that its fuel source, the sun, is completely free and practically limitless. The sun has been shining for about 4.6 billion years, and scientists estimate it will keep shining for another 5 billion years. That's a fuel supply we don't have to worry about running out of. Unlike fossil fuels, coal, oil, natural gas, which we dig out of the ground, the sun delivers energy to our planet every single day. Solar is a clean energy source. When a solar panel makes electricity, it does so silently, and without producing any harmful greenhouse gas emissions. No smoke, no smog, no carbon dioxide. This is critically important in our fight against climate change. By switching to solar, we can significantly reduce our carbon footprint, help keep our air cleaner, keep our water cleaner, protect wildlife, protect future generations. Every home or business that installs solar panels becomes a small, clean power plant. Now, as much as we love solar power, it's science. And in science, we have to look at the whole picture. There are a few challenges to consider. Solar panels need sunlight to make electricity. They don't work at night. So what do you do when the sun goes down? Most people on the grid simply pull power from the grid at night and send power back during the day. If you go completely off-grid, you need to store extra daytime energy to use later. That brings us to energy storage. The solution is batteries. Panel output depends on weather and time of day. At noon on a clear day, panels hit peak output. On cloudy or rainy days, they still make electricity, just less. While panel prices have fallen dramatically, the initial cost of a full system can still be a barrier for some families and businesses. But there are government incentives, tax credits, and financing options that can help. So what does the future hold for solar power? I can tell you, it looks incredibly bright. The science and technology behind solar energy are evolving at an amazing pace. Researchers are constantly developing new types of solar cells that are more efficient, meaning they can convert more sunlight into electricity from a smaller area. They're also making them from new materials. They're making them from flexible materials. They're making them from transparent materials. Imagine windows that are also solar panels, generating electricity while still letting you see outside. Flexible solar could be integrated into clothing. Flexible solar could be integrated into backpacks. Flexible solar could be integrated into the body of an electric car to help it charge on the go. We're also seeing solar power being deployed on a massive scale. Huge solar farms are being built in deserts and open fields. Those farms can generate enough clean electricity to power entire cities. These large-scale projects help transition grids away from fossil fuels. But solar power is also uniquely democratic. It can be small-scale, too. A single panel can provide light and power to a remote village that has never had electricity before. That change enables education. That change enables communication. That change enables small business. The partnership between solar power and electric vehicles is another game changer. Solar panels on your roof collect free energy from the sun. You can use that energy to charge your electric car in your garage. You would essentially be driving on sunshine. This creates a self-sustaining loop of clean energy for transportation, removing the need for gasoline and its pollution. Now that you understand the incredible journey of solar energy from a star millions of miles away to the outlet in your wall, you are part of the solution. Knowledge is power, and understanding how clean energy works is the first step toward embracing it. You can start by simply looking at the world around you differently. When you feel the sun on your skin, think about the immense clean power that is arriving on our planet every single second. The sun is doing its part. It shines for everyone. Now it's our turn to shine too. Think about it.